Welcome to this video. This is lecture number 5 or part 5 of the classical mechanics, and already 4 part are covered. The link will be given in description box. You can watch from this link. Okay, in this lecture or in this video we want to discuss about the rocket motion, that is the variable mass motion. Okay, so let's start. This will be helpful for physics honors of semester 1, also other examination you can see that. So let's start. This is the syllabus for the B.Sc Physics first semester of University of Calcutta. This portion, that is the portion A, portion B, already covered in the previous lecture. In this lecture or in this video, we want to cover this portion, that is the variable mass system or the motion of rocket. Okay, so start. This is the all total syllabus of the mechanics. We will cover uh, lecture by lecture. Okay, so sorry. So in the previous problem, we take mass as a constant. You know the force equation or equation of motion can be written as the mass into acceleration, that is d2r dt square is equals to mass into acceleration, or you can say that is the force is equals to dp dt. Force you can write as f, only you can write f, that is dp dt. This is the second law of Newton, second law of Newton's, right? Here in the previous problem we take this mass as a constant, that is this is the mv, and if we take mass as a constant we will write dv dt. But in case of rocket motion, when the mass or the fuel is ejected, that is mass is not conserved, so in that case we must be use this equation, right? So we cannot go to the that equation, we must stay with that equation in case mass is not conserved. When mass is not conserved, then we must return into that equation and we need to solve this equation. Okay, and in this video we actually discuss the two type of rocket motion. When this rocket is go through a horizontal motion, go to and the horizontal motion, and only horizontal motion without any external force, only horizontal motion without any external force. Okay, external force, this is number 1. And number 2 is the vertical motion. When the rocket will be launched, the vertical motion, that is like that, and this is the vertical motion. Here you must external force, obviously mg, acted towards the gravity. Here the external force will be exerted. Okay, gravitational external force exerted, gravitational, otherwise no external force, only gravitational force are exerted, gravitational force exerted, right? We already discussed two in these two cases. Okay, so let's start. First case, here the rocket motion in this free space, we take this rocket is moved in the horizontal plane, there is no air resistance, this is neglected, so the friction force or external force take as the 0. So this take this move along the x-axis, so the velocity of the rocket can be written as v into x cap. This is the unit vector, this is the magnitude, right? During the infinitesimal small time after t time dt time, d m prime mass ejected from the rocket. After some time, at this moment the mass will be m and velocity will be v. After some time, that is the dt time, this mass will be ejected with velocity u. So u will be minus u x cap, because it is in the opposite to the x direction, right? Now the linear momentum at time t is pt, will be written as this. So at time t the linear momentum will be mass into velocity, this is okay. At time t plus dt the mass will be reduces, velocity will be increases. So this is the m into v, that is the momentum of this rocket, and this is the momentum of this fuel, this is the momentum of this fuel. Actually this velocity will be with respect to u, so actual speed will be with respect to u, so actual speed with respect to reference will be like that. This is the speed of the fuel with respect to reference frame, and this is the speed mass of this fuel. So then there is no external force, the linear momentum must be conserved. There is no external force, the initial momentum and final momentum will be conserved. If you don't know, you must refer to the previous lecture. So these two momentum will be conserved. If we equate these two, write down mv, and this is that portion, and just evaluate calculated, you can get this expression. And after that you just can see this mb cancel out. This term will be neglected because these two are small, the dm prime small, dv prime small, the two small multiplication will gives you very small, negligible. And v d prime, this will be cancelled out, so only remaining term is 2 m dv and minus u dm. So m dv and minus u dm prime, right? And dm prime is nothing but the minus of dm, dm prime is nothing but the minus of dm, because the loss of the mass from the rocket, dm is the loss of the mass from the rocket, which is the mass of the ejected fuel. So these are to the negative side. So you will be get, and at when velocity is v0, mass will be m0, at mass when m, the velocity will be m. So if you integrate with that limit, you will be get this expression, okay. So this is the expression. And if you wants to know the thrust of thrust on the rocket will be minus u dm dt. The minus u will be the velocity of the exerted velocity, which we will take as a constant. So the thrust will be like that. This is the velocity of rocket with mass will be change, initial with the final change. This ratio, actually this velocity depend on this mass change of ratio. Next, for the vertical ascent under gravity, when the rocket will be go through the vertical motion, so the all things are similar to the horizontal, with additional there is a g, acceleration due to gravity attracted towards the surface. So the velocity will be taken as the vey, that is the y axis, and g will be minus because this acted towards the center. So we get velocity and acceleration due to gravity. Now from the previous problem we take this external force will be 0, but here external force not 0. So if you rearrange this, and dp will be the change, so the change of the momentum. In the previous case we take this as 0, but in case we do not take this 0. So if you just multiply, you will get the same two term in the previous one, like previous one, but here this is not 0, you will be, this will be minus mg, this is the weight along the y axis, negative y axis. So then just divided by m, and if we integrate it, you will be get, if we integrate here, just we integrate, just we integrate here, if you integrate here, just integrate. So this will be v0 to v, and this is 0 to t, and this is m0 to m, right? So if you put this values, you will get v minus v0, this is gt minus 0, and this is m minus m0, and this will be the expression of the velocity of the rocket under the vertical motion. I think clear. If there is any doubt, you must comment in the comment box. And if we take the burn rate, that is the fuel burn rate, that is will be constant. If you take this will be constant, that is the mdt will be constant. And if you integrate with the limit, sorry, if we integrate with the limit, that is m0 to m, 0 to t, so you will get m minus m0 minus alpha t, from where you will get expression of t time. And if you put this in place of time, you will be get this type of equation, you will be get this type of equation. This is the speed of the rocket at with respect to m and m0, okay. Here also we get the with respect to m and m0 and u, here also get the expression with respect to m, m0 and u, okay. I think clear. This is two problem homework, you must do these two problem. and comment in the comment box. So thank you. This is all about me. This is my contact details and this is my YouTube channel details. Go to this channel, you will be get the video which already uploaded. Share this video to your friends so that he or she also get benefit. Subscribe this channel if you new in this channel, and those already subscribed, thanks for subscription, and press the bell icon to get the notification of upcoming video. So take care, we will meet in the next video as soon as possible. Thank you.